we're going to identify the terms in this polynomial. Now, terms are quantities that are separated by plus signs. Now, maybe we remember from sign numbers that subtraction is really addition of the opposite. So if I wrote this one out without the subtraction signs, it would look like this. 3a to the fourth plus 2a cubed. Now change subtraction to addition of the opposite. This is going to be plus, and then a negative 5a squared plus 7a, and then this minus will change to addition of the opposite. Now, here are the terms. Quantities separated by plus signs. All right? So list the individual terms. We'll have 3a to the fourth. We'll have 2a cubed. We'll have negative 5a squared. We'll have 7a. And we'll have negative 2. So in practice, when doing this, you don't really have to do this. You don't have to change subtraction to addition. You just know it in your head. What you do to get the current terms is just take the sign along with it. So positive 3a to the fourth, positive 2a to the third, negative 5a squared, 7a, negative 2. Now what we want to do in this expression here is to identify the like terms. Now like terms are terms that have the same variable but perhaps different, the same or different coefficients. So look at the x. We've got 4 of them here, and then over here we've got 6 more. These are like terms. We'll write that 4x and 6x are like terms. Then look at these y's. We've got 8 of them here, 8 y's here, and then over here at the end we were going to subtract 3 y's. So these are the same, these are like terms. They're the same variable, but maybe in this case we have different coefficients. So we're going to have 8y and negative 3y. Now we also have this 5m, but we're not going to write anything with it because it's unlike anything else. There's nothing that matches it. You know what, let's make this problem number 2, and then let's do a number 3 up here. Let's do the same thing, identify the like terms again. Let's look at this one, 9ab minus 3b plus 4b minus an ab, and then plus a 7. So we've got 9 ab's here, and then we're going to subtract 1 over here. So for like terms, we have some ab, so let's write, we've got 9ab and a negative ab. Those are like terms. So now we're going to be given some factors here. And remember, factors are parts of multiplication, and we want to indicate their product. So how about number 4? We have these factors. Say we have 3x, and then we've got, say, an x plus 7, and then we've got an x minus 4. So we've got this factor. That's going to be a factor. This is going to be a factor, and this is a factor. So let's just indicate a multiplication. That just means we're going to indicate multiplying all these together. Now let's look at a division. Suppose we have a division that looks like this. Suppose it's written this way. Say 5x divided by 3y, and we want to write it as a fraction. What we're doing here is we're taking 5x and we're dividing the entire thing by 3y. So this one is going to look like this. 5x divided by 3y. So in problem number 6, what we have going on here is we have a cable that is 25 feet long, and from that cable we're going to cut a section that is y feet long. So what we want to do is write a formula that expresses the length of the remaining cable. You know, this is something we can draw, and if you can draw it, I suggest you do, because it just gives you a bigger sense of how to label things. So let's draw a cable. Maybe it's here and goes over to here. All right, and the whole thing together is 25 feet. Now what we're going to do is from this cable, we're going to cut a section that is y feet long. So come down to the cable. Just imagine yourself doing this. Here's the end of the cable. You're going to come y feet, whatever the y happens to be, 1 feet, 2 feet, 3 feet, whatever, and you're going to make a cut. So suppose you make that cut right here, and that this distance here is y feet. So what this problem asks us to do is write a formula that tells us how long this is in terms of L for the length. So what do you think this is going to be? We're going to write L equals, what do you think? Okay, if you're not sure, you're going to start with the 25 feet, right? Now what if you cut off 10 feet? What would it be? It would be 25 minus 10. So you'd write 25 minus 10, and you could actually do that, right? Getting 15. What if you cut 1 foot? Then it would be 25 minus 1. But you're cutting L feet off, so how about if we did this? What if we wrote it as 25 minus, y, right? We're cutting y feet off. So here's our formula that gives this length right here, gives that length in terms of this length. So here's a rectangular box, and what we want to do is, we have a formula for the area. So we're going to take the area of this end, the area of that end, and the area of each one of these sides and bottom and top here, and the formula for getting the total area turns out to be this. It is A, the total area is 2x squared plus 4xl. Not to worry where this comes from right now. We'll get to that sometime later. So what we're being asked to do is find the total area, surface area of this box. Find the total surface area, given that x is 2.94 feet. Okay, let's write that feet in here, and 5.07 feet for L. So let's substitute and compute. So we're getting A is equal to 2. Right now I'm just substituting right into this formula. There's the 2, and now the x. So the x, I'll write a parentheses to denote that multiplication, is 2.94 feet. And then we're going to square that, plus 4 times x, 4 times 2.94 feet, times L, which is 5.07 feet. Now, by the order of operations, we're going to compute that power first. So I did that on my calculator. I got A equals 2 times, now 2.94 squared is 8.6436, and when you square the feet, it's feet squared, plus, and we still have the 4 times 2.94 feet times the 5.07 feet. So let's make these multiplications now. And this first one, 2 times the 8.6 and so on, is going to be 17.2872 feet squared, or square feet, plus, now making this multiplication, that turns out to be 59.6232 square feet. Now it's square feet, right? Because you got feet times feet. So feet times feet will be feet squared. Now these are like terms, right? Look at what we have here. Feet squared. We got so many feet squared plus so many feet squared. So these are like terms. So we're going to go ahead and add them together. So I'm going to add 17.2872 and 59.6232 together. And when I added those numbers, I am getting A equals 76.9104 square feet. Now, we're going to have to round this off. This looks like it's way too accurate. We're not going to get that accurate. So do you remember when we make multiplications and additions, how we do this? So we make these multiplications. We're going to round to the digit that has the least number of significant digits. So coming back up here to our x and L, we have 3 significant digits, 3 significant digits. Let's round this to 3 significant digits. So our area we're going to claim is 76.9. Here's the 9. Now there's a 1, so we're going to round these off. Those are going to become zeros. Just drop them. And then square feet. Let's do one more problem. How about number 8? Suppose that we have this. There's a machine and it has a certain value, V. Now the value of the machine depreciates so that after T number of years, with original price P, here's the value. So after T years go by, the value of the machine is this much, where P is how much you bought it for and T is the number of years. So what we're asked to do in this problem is to do this. Find the value of this machine when you originally paid $1,750 for it and 6 years have gone by. So let's substitute these numbers. So we're going to get V equals 1750. Now I'm going to write DOL for dollars over T, which is 6 plus 1. So let's evaluate. So V is equal to $1750 divided by 7. So on your calculator, and I'll do it on mine, 1750 divided by 7 turns out to be $250. Right now it's still dollars. We still have the DOL. So what's the value of this machine? Now I'm not going to write it as V equals this. I'm just going to claim that it is $250.